calculate the enthalpy change. Enthalpy is just heat, or Q, when 25 grams of ice at 0.0 degrees Celsius is heated to liquid water at 26 degrees Celsius. Now, when you're dealing with these kinds of problems where you've got phase changes and temperature changes, making a heating curve helps you keep organized. Okay? During a phase change, so that occurs at the freezing point, during the melting point, so at 0 degrees Celsius, time is elapsing and all my ice is melting. But the temperature does not change during a phase change. Okay, you can either change phase or change temperature, not both. So first, we're going to melt all the ice, and that occurs at the melting point of ice, or in other words, the freezing point of water. So we're going to calculate how much energy that takes. We're going to use heat of fusion for that. Then once all my ice is melted, I'm going to increase the temperature to 26. So that's Q equals MC delta T. So that's two separate calculations I've labeled A and B. So the first time, we're going to do the ice melting calculation. Now the heat of fusion data are in a table on D2L. It's called physical constants. So download that. That's where this 6.01 comes from. So Q is equal to N, which is number of moles, times heat of fusion. So 25 grams, molar mass is 18.01. So that gives me my number of moles, and then we're multiplying it by the heat of fusion. This number comes from D2L. So that gives me 8.4 kilojoules. Now note, heat of fusion is in kilojoules, okay, because that's what it's reported down in my data table. Now we're going to do, once all the water is in the liquid phase, we're going to change the temperature. So Q equals MC delta T. So M times C. Now we're using the heat capacity of liquid water. Again, check out that data table on D2L. And the delta T is final minus initial. So it was initially at 0, it's now at 26. Now notice, this is in joules per gram degrees Celsius, so my final answer comes out in joules. I have to make these two units match so I can add them. I just converted this one to kilojoules. Now I add and I get my final answer. 8.4 plus 2.717 gives me 11. And I'm keeping 2 sig figs. Right? So my final answer is 11 kilojoules.